sum of the currents at any point in a circuit is 0. That's Kirchhoff's first law. For the mathematically inclined, we can express that in this form. You may or may not be familiar with the summation sign. This letter here is a capital letter sigma from the Greek alphabet, a capital sigma, and it means add together. And it means add together all the values of I, of current, the first current, plus the second current, plus the third current, till we get to the total number of currents. If there are 5 currents, capital N would be 5. If we expanded that, this symbology means I1 plus I2 plus I3 all the way up to the final current. And the currents add up to 0 if we use this convention of positive in, negative out. Let's use all that to see if we can do a simple calculation. Here's a circuit. We've got a network of resistors. So these two are in parallel with each other. These two are in series with each other. The first resistor has a current of 0.8 milliamps. The second has a current of 0.4 milliamps. The top resistor has 1 milliamp. I want to know what the current through this section of wire is at the top, I1, and what the current through this section of wire is at the top, I2. So if you want to pause the video for a moment and try and do this for yourself. Okay, well I hope you got the same answers as I'm showing on the screen. I've put the current directions in to help make the explanation a bit easier. Let's look at the junction on the top right. We know that the current leaving the junction is 1 milliamp and 0.4 milliamps, so the total leaving is 1.4. Therefore the total going into the junction is 1.4. I2 is 1.4 milliamps. What about the top left junction? Well, we know 1.4 milliamps is leaving it and 0.8 milliamps is leaving it. So the total leaving is 2.2. That means the total going into the junction must also be 2.2 milliamps. And if you want to check for yourself the current on the bottom, the currents match the top ones, 2.2, 1.4 and 1. Okay, I hope that's clear. Thanks for watching. Don't forget to learn about Kirchhoff's second law, which tells you how to deal with voltage